In UniFi Network Controller, if you go to some of your devices, for example, in my lab environment for this U6 Enterprise Access Point, under the Overview tab, you can see this information so-called load average. 3 numbers without any documentation, any help. So you may wonder what they are about, how you can decode their meanings. So in this video, let's talk about them. In the right side, let me SSH into this example access point. This load average information is part of the Linux kernel status. You may know Ubiquiti UniFi's network devices use Linux operating system. This information is not unique to UniFi devices. It's standard Unix, Linux kernel information, and you can use many different Linux commands to show the same information. For example, uptime, see this load average information, 3 numbers. More commonly, people prefer top command. See the third line, load average. You may observe for every 5 seconds, the load average information is refreshed. You may say that's simply because by default, your top command will do the refreshing every 5 seconds, right? If that's the case, let me kill the top command, run it again. This time, let me say refresh every second. Now you can see the process information is being refreshed every second, but if you take a close look into the 3 numbers, they are still refreshed every 5 seconds. The reason behind it is it's part of the kernel, it's hard-coded. Linux will refresh the load average data every 5 seconds. If you want to know official explanation from Linux about load average in a standard Linux system, for example this Debian, you can take a look at the menu for, let's say, uptime. In this paragraph, it explains load average. It counts the runnable or uninterruptible state processes. We can talk about the states later. What are the 3 numbers? They are for the past 1, 5, and 15 minutes. Even after reading this document, you may still have trouble understanding what the number really means, right? In this video, there will be 3 parts. The first part, let me give you a demo to show you how the 3 numbers work in action. In the second part, dig deeper. Let's talk about in general in Linux how the load average is calculated. And the third part for the video, let's look into specifically for UniFi network devices why Ubiquiti chooses to show this number. You can see now the U6 Enterprise Access Point is in idle mode. No Wi-Fi clients connected to it. Nothing's happening there. You can tell from the top command output. So the load average is pretty low. In the lower part of the window, I already prepared 3 Linux sessions. I just SSH'd into the same access point. In the 3 SSH sessions, let me run the same command. It's a simple command, seq, generate sequential number, just to keep the CPU super busy. Kick them off in the 3 sessions. So note down the time. We are going to count the 1 minute, 5 minutes, and 15 minutes starting from now. So see the top output. The first 6 processes listed, 3 of them are the same command seq, right? What are the other 3? Ubiquiti use a tool called dropbear to run as SSH server in the UniFi devices. The other 3 processes, they are just the server-side SSH sessions, and then the 3 seq commands are the ones I just kicked off, right? So all the 6 top processes are related to my 3 test sessions. And you can see the CPU is super busy, 100% busy, and the load average is already climbing. We are approaching 1 minute. You can see the first value is over 6 already. Where the 6 come from? Because we just added 6 busy processes which are running all the time. If you check the state column I just highlighted in yellow color, you can see whole bunch of R. So R means running. That's the exact state Linux will count when it calculates the load average. In the middle, there's a top command, which is also showing R all the time. And for the 6 top commands, sometimes some of the SSH server part will show S, which means sleep. So sleep processes won't be counted in the load average at any given moment. If you count the running processes, the number will be 4, 5, 6. The delta will be more than 4 if you compare to the state before we kick off the 3 busy sessions. 2 minutes just passed. Let me fast forward. Let's check the 5 minutes status. Okay, 5 minutes passed. You can see the first number for the load average already exceeded 6, and the second number is approaching 5. Now let me fast forward again. Let's check the final status after 15 minutes. Okay, after 15 minutes super heavy torture to the CPU, as you can see, we have a pretty stabilized 3 load average numbers. So as we read from the Linux document, the 3 numbers are for 1 minute, 5 minutes, and 15 minutes load average. Now let me queue the 3 heavy sessions. Let's see how the 3 numbers will change in 1 minute, 5 minutes, and 15 minutes. Okay, let's count the time starting from now. Fast forward to 1 minute. The first numbers dropped dramatically. Okay, fast forward to 5 minutes. Okay, now the first number dropped to below 1. Second number also dropped a lot. Continue, fast forward. Let's see the final status after 15 minutes. Okay, this is the end of the 30 minutes testing. You observed the up and down of the 3 numbers with the different processes running, right? Now let's try to understand how Linux calculate these 3 numbers. On the screen, I show you 2 articles about this load average topic. The author calls the 3 numbers LA triplets. LA stands for load average. There's some interesting history mentioned in the document. For example, about Sun Solaris, it had a bug, and only after a specific version, the load average values were calculated correctly. Even for those big guys, those 3 numbers sometimes were also confusing. It has a graph show you a example similar to what I just did in the beginning of the video. As you can see, the 3 curves. This very deep one was for 1 minute, the green one for 5 minutes, this one for 15 minutes. In the end, they are all approaching the number 2 because in the author's testing, he had 2 super busy processes. In my testing, I had totally 6, but we had similar result. In the end, all the 3 numbers will approach to the particular value if all your processes are super busy. And starting from this part, it really touched the core of the topic. It listed the Linux kernel source code. So the load average is calculated in kernel in this calc load function. It looks super simple, right? It's simply call the 3 macros and each time use a different constants for 1 minute, 5 minutes, and 15 minutes. And this method is called every 5 seconds. hard-coded in Linux kernel. Then later, the author explored the expressions, how the so-called average is really calculated. If you are interested in mathematics, you may want to look into the details. In this video, let's directly jump to the summary from the author. How you interpret the word load. The load is not the CPU utilization. It's not the percentage, 100%, 0%. No, the load is the total queue length. Basically, the Linux kernel will take account of the processes which are in running state or it's in the so-called uninterruptible sleep state. If you run the command top, sometimes you may see them. They are showing in the status capital letter D. Basically, it means those processes are waiting for I/O resources, so they cannot be interrupted. Either your CPU is busy running a process, or your process in the waiting queue to be run by the CPU, or your process is waiting for an I/O resource so that it's in the uninterruptible sleep mode. Linux kernel will count these three type of processes when it calculates the load average. The second thing is very important. They are point samples because the kernel can only do the sampling every 5 seconds. Think about it. When the kernel is running that particular load average function, your originally super busy job may happen to be in sleep state, or you happen to have many small processes. They happen to run at the moment when the kernel count the processes. So all the fluctuations may impact the results. That's what the point sample means. It's counted every 5 seconds, not all the time. And then the third point is exponentially damped moving averages. As explained in the right side second article, title mentioned, the load average is not the normal average you think about. It explains why it uses this type of average. It simply wants to do the smoothing of the curve. Because of the fluctuation, because of the point sampling, Linux wants to give you a value which more reflect the trends instead of the real-time value, because that value may not be really accurate if you look at it from a wider time range. So that's why special algorithm is taken. I don't want to bore you with all the math details. As long as we understand the summary, that should be fine for the purpose of this video. Okay, having discussed how the load average works in Linux in general, finally it's time to talk about why Ubiquiti include the load average information in UniFi network controller for some UniFi devices. You may know for many network devices, the real network work is not really done by the CPU. It's by dedicated chips within the device, right? So the load average is part of the Linux kernel. It's for the CPU of the device. Ubiquiti does have the load average included in the access point information, right? Let's do a simple testing. So now you can see from the network topology, I already connected 3 Mac machines using Wi-Fi to the access point. So then let me run iPerf3 testing from each one of them, and let's simulate some very heavy network traffic. Then let's see whether the load average information has any difference at all. You can see now the load average values just a little bit about 2. Let me kick off the 3 iPerf3 testing. By the way, the iPerf3 servers are running in Linux virtual machines connected to the switch using Ethernet cable. They are all running. So from the top command output, you can see even for the 1 minute value, yes, it is increasing a little bit, but not too much. I don't really see any big jump. So let's give it some time. Let's see after 1 minute, 5 minutes, whether anything will be changed. Okay, 5 minutes passed. As you can see, the 3 numbers for load average, they didn't jump. Apparently, no matter whether your Wi-Fi traffic is light or heavy, it really doesn't impact the load average at all because it's not CPU does the job, right? So then what other tasks the access point may do? They may impact the load average. Yeah, we can do another testing. For example, let me try to change some access point configuration and then do the provisioning. In UniFi Network Controller for this U6 Enterprise access point, let me go to setting. If I want to change the 5 GHz radio band's transmit power from current high to, let's say, medium, it's just a small change, right? See the right side, the current load average for 1 minute is 1.7 something, right? Then let me apply changes. The configuration just started. See, in the right side value, you can see a slight jump about load average. That makes sense because apparently there were some processes need to be done by the CPU to accept the configuration change and to carry out the changes, right? But not too big. Again, it doesn't really matter. What's the point UniFi chooses to include the load average in the UniFi network controller for the AP? In fact, UniFi doesn't show the load average in all the devices. For example, for the switch, even though this is an enterprise switch, for the overview tab, if you scroll up and down, you won't be able to find the load average. Even though this switch is running on Linux for sure, even though the load average information is available in Linux, UniFi decides not to show the load average for the switch. For the router, UDM Pro, yes, you can find the load average. This decision makes sense because for UDM Pro, it need to take a lot of CPU intensive activities, for example, all the firewall, the filtering settings, right? The load average may have some value because you want to know how busy the CPU is. But again, go back to the access point. I'm still puzzled why the load average information is shown for access points. If you know the answer, please let me know. Okay, this is the end of the video. Thanks for watching.